Hi everybody, it's Mr. Davis, and in this lab we are going to demonstrate the use of a Spectronic 200. It's a UV visible spectrophotometer. These are very common units. I've got a cell holder. My cell is a cuvette, and that's a 1 centimeter by 1 centimeter path length. The light will shine from right to left through the sample and give me an absorbance, how much light that absorbs at a given wavelength. So the first thing you do when you come to the instrument, you're going to turn it on, and you have to wait for the light to warm up. And the reason is because it's basically a light bulb in there, and it'll give an uneven light output for the first 15 or 20 minutes or so. So this instrument is warmed up, so we're good there. And I take a water blank. We just call that a blank because it's essentially water, and it's hard to see, but that is just water in there, deionized clean water. And I would insert that into the cell compartment, and then I am going to press the button for 0, and that's called just, running my blank. I'm going to zero that out, and as you can see, it says it's performing an auto zero. I'll know when this is done because the absorbance should read 0 when we're done. And it's done. So I can remove my blank, but first I'm going to show you some of the solutions we've got. We've got a red aluminon, and what that is, it's an indicator. We use it in other labs, in an aluminum lab for a precipitate. And I've got a couple of different concentrations here. On the left, it's 10 grams per liter of this aluminon stuff. And on the right, I've got 20 grams per liter of aluminon. And you can see clearly the one on the right, the more concentrated one, is darker. And that would mean that it would absorb more light. The absorbance would be higher. You can see that pretty clearly there. Here we have copper sulfate. We've got a 0.1 molar on the left and a 1 molar on the right. So a much more dilute on the left and more concentrated on the right. And you can see, again, the same pattern. The more concentrated it is, the higher absorbance we would expect. And you can see that because it would absorb more light. It's darker. Okay, and here you can, even though these are the same, the path length is what gets you. So this thing right here, this is a 1 liter beaker, and it looks darker blue, but that's just because it's got the more path length. So finally, we've got nickel nitrate, and this is what I will run a sample of for this demonstration. And we've got 0.1 molar on the left and 1 molar on the right. So you can see that the less concentrated nickel nitrate, clearly less dark, higher absorbance on the 1 molar, more concentrated solution. So coming back to the spectrophotometer, we got the water solution in there. We do our 0. And while that's zeroing, I'm going to go ahead and grab a 1 molar solution of the nickel nitrate, and just making sure we've got our 0, and it's zeroed, so we're good. Remove the blank, put in the sample, and now I'm going to dial in the wavelength. That's the wavelength right there, and there's the absorbance. So I'm going to put this all the way over to 400. That's where you're going to start. At 400 nanometers, this sample absorbs 0.680, and I would record that. And here I've got a little chart, and I would write this down. At 400 nanometers, I would write the value that I had obtained. So we just basically are going to step through this 10 nanometers at a time. 400, now 410. My absorbance is 0.75 or 0.73575. It takes a minute to stabilize. in the simulations, the numbers probably won't fluctuate like this, but this is the real world. So then 420, and I would record a 0.716, and then 430, 655. There it is, 655, 440, and now we're trending down 0.613. 450, 0.551, and so on. So basically I'm going to go all the way from 400 to 700 nanometers, rotating the knob or adjusting the wavelength, and I'm going to record that. Once I get all of my data in a table like this, then I'm going to graph the wavelength on the x-axis and the absorbance here in this column. That's going to be on the y-axis, and then I'm going to get what's called an absorption spectra or spectrum, and it could look like that or anything else. Now I'm going to show you a neat feature. This won't take long, and essentially these modern instruments will do all of this for you very quickly in one scan. There's a couple of different ways they can do it, but in this case we call it a scan. There's other techniques, but you'll cover that later. So I'm going to grab my nickel nitrate and put it in. This instrument has already been zeroed, and I'm going to scan, and what it's doing is it's scanning all the wavelengths from 400 to 700, and it's putting it in a plot, and there we have it. And so we can see that this green nickel nitrate has peaks at down here just around a little over 400, and I've got the cursor set at 633. So the lambda max for nickel nitrate is 633 nanometers, and at that wavelength I'm showing an absorbance of 1.18. So that's some pretty nice data right there. And that's really all there is to it. You're just basically going to collect the absorbances at every wavelength and plot that. Okay, that's it for this video. See you next time. Bye.